As much as 85% of today's industrial machines are driven by electric motors. It is important that the technician has an understanding of these workhorses of industry. A split-phase motor is an AC motor of fractional horsepower, usually 1/20th to 1/3 horsepower. It is commonly used to power oil burners, blowers, and small pumps. The split-phase motor is made up of three primary parts: the rotating member called the rotor, the stationary member called the stator. The stator is made up of the start and run windings, and a centrifugal switch that is used to disconnect the start winding at approximately 75% of the full load speed. When starting, both the run and the start windings are connected in parallel across the line. The run winding is generally constructed of heavy insulated copper wire. When the motor reaches about 75% of full speed, the centrifugal switch opens, disconnecting the start winding to allow the motor to operate on the run winding only. To reverse the operation of a split-phase motor, simply interchange the leads of the start winding. Whenever possible, check the manufacturer's wiring diagram for specific information. The graphic shown here illustrates the terminal connections and wiring diagram of a dual voltage split-phase motor. All windings receive the same voltage when wired for low voltage operation. When wired for high voltage operation, the start winding is in parallel with only one of the run windings to provide the proper voltage distribution. It is important to always check the motor manufacturer's wiring diagram, since all motors may be different. Capacitor start motors range in size from 1/8 to 10 horsepower. These motors are commonly used to operate compressors and air conditioners. The construction of the motor is similar to the construction of the split-phase motor, with the addition of a capacitor that is wired in series with the start winding. This additional component gives the motor higher starting torque than the split-phase motor. Like the split-phase motor, a centrifugal switch is used to disconnect the start winding at approximately 75% of full speed. Reversal of the capacitor start motor is accomplished in the same manner as the split-phase motor. Simply reverse the connections to the start winding. As with all motors, be sure to check the manufacturer's wiring diagram for specific information pertaining to wiring. Permanent split capacitor motors differ from the motors previously discussed in that the capacitor and run winding remain connected continuously during both starting and running. A lower value capacitor is used in the permanent split capacitor motor than in capacitor start motors. This allows the motor to have medium starting torque and a higher running torque than the capacitor start motor. It is again possible to reverse the rotation of the motor by interchanging the leads of the start winding. Specific information pertaining to wiring should be found in the manufacturer's wiring diagram. A two-value capacitor start motor uses a high and a low-value capacitor connected in series with the start winding for starting. This gives the motor high starting torque. When the motor reaches 75% of full speed, a centrifugal switch will connect the high-value capacitor from the circuit. The low-value capacitor is left in the circuit, providing high running torque. Reversing of the motor is also accomplished by interchanging the leads to the start winding. Always check the manufacturer's wiring diagram for specific information concerning the wiring connections. Three-phase motors are internally constructed with a number of individual windings. Regardless of the number of windings in the motor, they are always connected either in series or in parallel to produce three distinct windings called phases. Each phase will contain 1/3 of the total number of individual windings. Three-phase motors vary from fractional horsepower to several thousand horsepower. They also have good constant speed characteristics. Y-connected three-phase motors are wired so that all phases are connected to form a Y configuration. One end of each phase is connected to the other phases. Reversing a Y-connected motor is simple. The direction of rotation may be reversed by interchanging any of the three line leads. NEMA recommends that phases L1 and L3 be interchanged, but any two will reverse the motor. The graphic shown above depicts the high and low voltage connections for a 9-lead Y-wound motor. For high voltage operation, leads 4 and 7 tie together, leads 8 and 5 tie together, and leads 6 and 9 tie together. Leads 1, 2, and 3 connect to L1, L2, and L3. The wiring for low voltage calls for leads 1 and 7 connected together and then connected to L1. Leads 2 and 8 tie together and connect to L2. Leads 3 and 9 connect together and tie to L3. Delta wound motors connect the windings end to end to form a completely closed loop. At each point where the phases are connected together, leads are brought out to form the terminals. The direction of rotation may be reversed by interchanging any of the 3 line leads. NEMA recommends that phases L1 and L3 be interchanged, but any 2 will reverse the motor. The graphic shown above depicts the high and low voltage connections for a 9-lead delta wound motor. For high voltage operation, leads 4 and 7 tie together, leads 8 and 5 tie together, and leads 6 and 9 tie together. Leads 1, 2, and 3 connect to L1, L2, and L3. The wiring for low voltage calls for leads 1, 7, and 6 connected together and then connected to L1. Leads 2, 8, and 4 tie together and connect to L2. Leads 3, 9, and 5 connect together and tie to L3. Drum switches are manually operated devices that consist of moving contacts mounted on an insulated rotating shaft. The moving contacts make and break contact with stationary contacts as the shaft of the drum switch is rotated. Drum switches are totally enclosed with an insulated handle that provides a means of rotation of the shaft. Drum switches are not motor starters because they do not provide any means of overload protection. Usually, overload protection is accomplished through the use of a magnetic or manual starter. When the handle of the drum switch is in the off position, none of the switch's terminals are connected together. When the handle is moved to the forward position, terminals 1 and 3 connect together, terminals 2 and 4 connect together, and terminals 5 and 6 connect together. For reverse operation, terminals 1 and 2 connect together, terminals 3 and 4 connect together, and terminals 5 and 6 connect together. Although the graphic shown here illustrates the use of a 3-phase motor, drum switches may also be used on single-phase motors as well.